Say what? What are we going to talk about next? Oh, this is just building on top of each other. So, there's another relationship that we want to start thinking about. And given characteristics about a function, would we be able to sketch the graph of the first derivative, which would be f prime of x, and the second derivative, y double prime, which equals f prime of x. Double prime. I gotta get that in there. It's double prime. So, when we were graphing our polynomials, we were focusing, on one of two characteristics. One, what were going to be the x values, and two, what was going to be that end behavior. And what we need to illustrate that when the first derivative equals 0, that's going to imply that you have horizontal tangents. So if you have a horizontal tangent out of a slope 0, here, that would be a horizontal. Then you have a horizontal here, and then you would get another horizontal, and then you have one here, and then will be another horizontal. And what this illustrates, when the first derivative is equal to 0, then the graph, right, has the graph of f at least have these critical values, which are relative mins or maximums. However, this f prime of 0 is going to illustrate where the first derivative crosses the x axes. So when you take a look, and all of this is in that handout, right? So we estimate points of f prime of x given f of x. And we can estimate the value of the derivative at any value of x by drawing a tangent at a point of x at f of x. We're estimating its slope. So the slope of the graph of f becomes the y value of f of x. And the horizontal tangent is where the slope of the tangent is 0, i.e. f prime of 0. So for this graph, we illustrate it. This would be the 1. This would be the 2. And this would be the 3rd. And now you also want to be mindful that these slopes here are going to indicate that f prime is going to be less than 0, where these slopes here are going to indicate f prime is going to be greater than 0. And then from here, here, all the way down, then that indicates that yes, f prime is going to be less than 0. And then here, you're going to get f prime to be greater than 0. And notice, as the first derivative changes from negative to positive, you have this slope of a tangent, which is a relative minimum. At here, the slope changes from positive to here negative. That critical value is a relative maximum. And here, you see that the first derivative changes from negative to positive, and that's a relative minimum. And so, what is this saying? So that goes to show you that here would represent the x-intercept for your derivative. And since these values here, 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 here are negative, that's why these values here are negative. Then these values here are positive. That's why these values here are positive. And then you notice at this 1.5, that's where you cross the axes again, and then your slope changes. So you decrease, decrease, decrease. And then you get to here, where you have this intercept, and you notice that as you're going down, 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 and then here you're going up, 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 up to this value there. So it is a little bit of work.